All right, everybody, welcome to the video here for lesson number 2 of our little extension unit. So we're going to take what we learned in lesson 1, these exact values for sine, cosine, and tangent within quadrant 1, and kind of extend that idea beyond unit 1 into the other quadrants and even for some larger and smaller coterminal angles. Kind of exactly what we did in the regular unit, just we're looking for the exact values now, not just coming up with a ratio of segments. So the opening exercise I would like you to try real quick on your own. So take a minute here, pause the video, and try the opening exercise. All right, so welcome back. Hopefully you paused the video and actually tried this yourself and you're not just watching me do it. So it says, what is the reference angle for 240? Well, we know 240 is in quadrant 3, and the reference angle in quadrant 3 is take the rotated angle and subtract 180. So the reference angle here is 60 degrees. Because we're in quadrant 3 and we know that in quadrant 3 tangent is positive, meaning sine is negative, we know that sine is negative. Lots of reasons why we can say that. The main reason is because on the unit circle, y values are sine, and in quadrant 3, the y values are negative. That is the reasoning behind that. Okay, so knowing that the reference angle is 60, knowing that it's going to be negative value, what's the sine of 240? So basically, if you remember from the last part of the chapter, what we would have written would have been this. Well, now we can go one step further and say, well, I know what the sine of 60 is. So this answer is negative square roots of 3 over 2. This idea is what we're going to do in this big chart. So what we're going to do for this chart is I'm going to do quadrant 2 with you. I'm going to tell you to pause the video and then try quadrants 3 and 4 yourself. So one of the things that we have to be able to do is to quickly convert from degrees to radians or radians to degrees. So a couple degree values that we should know from yesterday's lesson is pi over 3 is 60 degrees. Pi over 4 is 45 degrees, and pi over 6 is 30 degrees. The reason why these are important is if I have 120 degrees, I essentially have 2 pi over 3s. So this value in radians is 2 pi over 3. That's how I can quickly convert these special angles. The reference angle in degrees, well, in quadrant 2, the reference angle is 180 minus the angle. So if I do 180 minus 120, I get 60 degrees. And we know the reference angle then in radians as well is pi over 3. So again, being able to quickly convert between the two types of measurement of angle is going to be kind of important here as we move on. So because we're in quadrant 2, we know sine is positive. So the sine of 60 is going to be the same as the sine of 120. Well, the sine of 60 is square root of 3 over 2. We know cosine is negative. So the cosine of 120 is going to be the negative of the cosine of 60. The cosine of 60 is 1/2. So this is going to be negative 1/2. We also know that tangent is negative in quadrant 2. So we can say, well, since tangent's negative, it's going to be equal to the tangent of 60. And we know the tangent of 60 is square root of 3. It's going to be negative square root of 3. For 135 degrees, to quickly convert that to radians, we would say how many 45 degrees is in 135? There are 3 of them. So there's 3 pi over 4s. So we'd say 3 pi over 4. If you're not getting how I'm doing that quickly, just do your normal conversion. Just do the 135 times pi over 180 and then simplify it just like we did in the last chapter. The reference angle is 45. We know that because we're saying 180 minus 135. That's how we get 45 degrees. That's even helping us find this radian angle. And the radian reference angle then is pi over 4. So if we're at 135, I know that the sine of 45 is square root of 2 over 2. I know that the cosine is negative, and it's also going to be square root of 2 over 2 because of that reference angle of 45 degrees. And we know tangent's 1, but since we're in quadrant 2, it's going to be negative. So basically, this is just us figuring out what the reference angle is, knowing the exact value of that reference angle, and saying, where are we? Are we in quadrant 2, 3, 4, and what's positive or negative in that quadrant? 150 degrees has a reference angle of 30. And we're going to say how many 30-degree values go into 150. There are 5 of them. So we'd say we have 5 pi over 6s. That's how to quickly convert that. So this would be a reference angle of 30, and this would be pi over 6. Well, the sine of 30 is 1/2. The cosine of 30 is square root of 3 over 2, but since we're in quadrant 2 for 150 degrees, it's going to be negative. And the tangent of 30 is square root of 3 over 3, and we would say that's negative as well because we're in quadrant 2. So go ahead, pause the video, try quadrant 3, then try quadrant 4, unpause it and check it periodically just to make sure you're on the right path. All right, so hopefully you've paused and now you're unpausing to check. I'm going to go through these a little bit quicker than I did quadrant 2. But looking here, these 3 angles are in quadrant 3. And these 3 angles are in quadrant 4. I already know the signs of all those things because of what quadrant we're in. So for 210 degrees is going to be a multiple of 30. There are 7 30 degrees, so 7 pi over 6, 30-degree reference angle, pi over 6 as a radian measurement. We're going sine, cosine, tangent here. Yes, make sure. All right, so we have sine of 30, but it's negative because we're in quadrant 2. Cosine of 30, but it's negative because we're in quadrant 3, not quadrant 2. And tangent of 30 is going to be positive there. 225 is a multiple of 45. So we're saying to ourselves, well, how many 45s go into that? Would be 5 of them. So 5 over 4, 45 degrees, pi over 4. We know these are going to be square root of 2 over 2s, and both sine and cosine are going to be negative, and tangent's going to be 1 and be positive. 240, the reference angle is 60, and there are 4 60s that go into 240, so 4 pi over 3, 60-degree reference angle, pi over 3 for our reference radian measurement. For 240, 60-degree reference angle, this would be square roots of 3 over 2, but negative. This would be 1/2, but negative, and this would be positive square root of 3. 300 has a reference angle of 60. There are 5 60s in 300, so 5 over 3 pi. That's 5 pi over 3, sorry. We have 60 as our reference angle, and we have pi over 3 as our reference angle as well. Quadrant 4, we know sine is negative. So we have negative square root of 3 over 2. We have positive 1/2 for cosine. And for tangent, we're going to get negative square roots of 3 because of what quadrant we're in. 315 should come out to be 7 pi over 4, 45 degrees, pi over 4, square root of 2 over 2 but negative, square root of 2 over 2 but positive, and 1, and negative. 330 should be a 11 pi over 6 because there's 11 30s and 330. 30 degrees, pi over 3. For 30 degrees, we have 1/2, but negative, square root of 3 over 2, and positive, and negative square roots of 3 over 3. So we can see a lot of this is all pattern-based. This will make more sense, too, once we start graphing and seeing how the flow of these graphs look. But looking for patterns, looking for those kind of things to help us do this is important. But basically, it's all coming back to the reference angle and what quadrant we're in, which is what we spent a ton of time on in the last part of this chapter. So now that we have this whole big chart filled in, we can answer questions like number 2. So if I have 840 degrees, what we learned in the last chapter is we want to find a coterminal angle to that. So I'm going to subtract 360 away from that twice, and that's going to leave me with 120, which is a quadrant 2 angle. So if I wanted to draw a quadrant 2 angle here, I would start by making the initial ray, which a lot of you forgot to do on the quiz, make 2 full circles, and then terminate somewhere over here in quadrant 2. Now, what we mean when we say coterminal is if I drew the 120 angle on top of this one, they would actually have the same exact terminating spot or ray, meaning the reference angle, the angle that we're getting at this point on the unit circle, everything's going to generate the same sine, cosine, tangent values. So the second part says state the coordinate where the terminal ray of an angle 840 intersects the unit circle when drawn in standard position in exact form. So when we're talking about a coordinate, right, we're talking about like a point on the unit circle. We'll call this point P. Well, this would be where the cosine of 120 is, or the sine of 120 is in the y column. We can even convert that to the reference angle. Since we're in quadrant 4, it would be negative cosine of 60, comma sine of 60, because we know that the cosine of 120 is the same as negative cosine of 60, which is why the x-coordinate's negative. And we can say, well, we know that the cosine of negative 60 is 1/2, so it's negative 1/2, and square roots of 3 over 2, because that's what the sine of 60 is. So essentially, we're finding this coordinate by knowing that anything on the unit circle is in the form of cosine of the reference angle, comma sine of the reference angle, just taking into consideration where you are, whether it's positive or negative. We do the same thing with negative angles. So if you take negative 1, 1, 2, 5, and you continuously add 360s, keep adding them. I think you have to add it 4 times, maybe 3 times, and you get 315 degrees, which is a quadrant 4 angle. So if you were to draw this, right, the sketch of this would be kind of crazy, but you would start with your initial ray. You'd go around 1, 2, 3, and then go around another 315 degrees. All right, so you'd wind up terminating and ending way over here. Boom, there's your angle. The sketch is not that important. I get that it's a little confusing when you start wrapping it all around, but just knowing that you are going in the negative direction is the important part here. So this point on the unit circle, point P, has a coordinate of cosine of 315, comma sine of 315. But we know that 315 has a reference angle of 45. So this is the cosine of 45. And since we're in quadrant 4, it's a negative sine of 45. And we know from our chart, the cosine of 45 is the square root of 2 over 2. And the sine of 45 is negative square root of 2 over 2. All right. Moving right along. So on number 4, it says determine an angle in radians that's coterminal to the angle 22 pi over 3. So right away, if you know anything about what we did in that huge chart on the previous page, you saw any kind of pattern, you see this is divide by 3. You know that the reference angle is going to be 60 degrees without really having to do any work here, right? But what I would do for this is I'd first convert this. So I'd say 22 pi over 3 times 180 over pi. Cancel that out. Reduce that to 60. Multiply that across and get 1320. only because it's easier to figure out the coterminal angles when it becomes a degree measurement. And start subtracting 360s until you get one that works, and eventually you'll get 240 degrees. So 240 as a radian measurement, if I do 240 times pi over 180, that is going to give us the fraction 4 pi over 3. So 4 pi over 3 is coterminal to 22 pi over 3. Now, what I could do here is figure out, well, I know what quadrant we're in. This is quadrant 3. I know the angle. I know the reference angle is 60 because of the divide by 3 in radian measurement, or because I did 240 minus 180 to find the reference angle of 60 degrees. So there's a lot of different things here that are all connected. So since it's the reference angle of 60, I can find the cosine of 60, which we know is 1/2. I can find the sine of 60, which we know is square root of 3 over 2. And I can find the tangent of 60, which we know is square root of 3. So that means I can find the secant of 22 pi over 3, which is the reciprocal of cosine. Knowing it's in quadrant 3, it's negative 2 over 1. I can find the cosecant of 22 pi over 3 by saying I know it's in quadrant 3, I know it's the reciprocal of sine, so I know it's negative. I'm going to flip this fraction 2 over the square root of 3, and since we want exact form, we are going to rationalize and get negative 2 square roots of 3 over 3 for cosecant. I can find the cotangent of 22 pi over 3 by saying I know it's in quadrant 3, so I know this is positive. I know it's the reciprocal of the square root of 3, and then I'm going to rationalize that to get the square root of 3 over 3. So I can actually find these three answers just by knowing what quadrant I'm in, what the reference angle is, and what some of the exact values are of the basic functions. Right? So I'm applying those basic ones to these bigger angles. Number 5 is a pattern that we've kind of described here throughout. So basically, if the radian measurement is over 3, the reference angle is 60. Over 4, the reference angle is 45. And over 6, the reference angle is 30. So for example, if theta is 137 pi over 6, I know because it's over 6, that reference angle is going to be 30 degrees. It's really that simple, right? Just knowing what this number on the bottom is tells us which one these are. Now, if it's not 6, 4, or 3, it's just a random number. It's not one of these special exact values that we're looking at. All right, so for number 6, it says state the exact value of the sine of 315, cosine of 135, and tangent of 300. So 315 is in quadrant 4. The reference angle is 45, so we would say negative sine of 45. Cosine of 135, that's in quadrant 2, so it's going to be negative, so we'll change this to a minus. And again, the reference angle is 45. Tangent of 300, that's in quadrant 4. We know tangent's negative there, so we'll make that subtraction. And we will say that has a reference angle of 60. Sine of 45 is the square root of 2 over 2. Cosine of 45 is the square root of 2 over 2. And the tangent of 60 is the square root of 3. We can simplify this and say I have negative 2 square root of 2 over 2's minus 1 square root of 3, which is equal to negative square root of 2 minus the square root of 3. That is our exact answer. I can't combine those because they're not like terms. At this point, I'm hoping that you understood everything that I was just doing. Please take a moment and try the practice problems. You can pause the video and then go ahead and come back to it if you would like to check your answers. All right, so hopefully you pause the video and now we're just checking. So for 210, the reference angle here is 30. Cosecant is the reciprocal of sine. Sine of 30 is 1/2, so the reciprocal of that is 2. Since it's 210, that's negative because sine is negative in quadrant 3. Secant's the reciprocal of cosine. The cosine of 30 is the square root of 3 over 2. So the cosine of 30 is square root of 3 over 2. So if we take the reciprocal of that, we're going to get 2 over square root of 3. So we'll multiply top and bottom by that. So we're going to get 2 square roots of 3 over 3, again, knowing we are in quadrant 3. So that is going to be negative. Cotangent. Well, tangent of 30 is square root of 3 over 3. So if I flip that, I get this. I rationalize, and I get 3 square roots of 3 over 3, which reduces to just the square root of 3. For 135, the reference angle is 45. Cosecant's the reciprocal of sine. Sine's positive in quadrant 2. This is going to become just the square root of 2. If you take the reciprocal of square root of 2 over 2, you get this. If you rationalize it, it will just become the square root of 2. Well, we know that 45 for sine and cosine is the same value, so that's just going to become negative square root of 2. And in quadrant 2, tangent and cotangent are both going to be negative 1. 300, the reference angle here is 60 degrees. So if we find the reciprocal of sine of 60 is square root of 3 over 2. We've already rationalized that reciprocal over here. All right, keeping in mind the patterns, like when one value is going to equal the other. So like sine and cosine, when the two angles add up to 90, they're the same value. So same thing happens with secant and cosecant, if you haven't noticed that yet. Since we are in quadrant 4, we know that sine has a negative value. So this is negative 2 square roots of 3 over 2. That doesn't look like a 3. That does. For 60 degrees and cosine, that would be 1/2. The reciprocal of that is 2. But since we're in quadrant 4, it's going to be a positive 2. Cotangent of 60, well, that would be the reciprocal of the square root of 3. So you'd have 1 over the square root of 3, which when rationalized will become the square root of 3 over 3. And since we're in quadrant 4, it is negative. Determine an angle that is coterminal to negative 2,370. So we are going to keep adding 360 until we get something that is going to be a nice positive number. So I'm going to add 5 of them, 6 of them, 7 of them. So if I add 7 360s, 150 degrees is coterminal to that. If you wanted to get really crazy and draw that, since it's negative, we'll start by going backwards. So I'll start here with our terminal array, and we're going to go around 7 times. 1, 2, 3, 4, 5, 6, 7, and then another 150. And we'd eventually terminate way over here in quadrant 2. Again, the crazy spiraling of the picture doesn't really matter to me so much. I just need to get to this number. So since we want to know the coordinate, we would say this is the same thing as the cosine of 150, comma the sine of 150. Well, we know that cosine of 150 is going to have a reference angle of 30, and it's going to be negative because of what quadrant we're in, and sine of 30 as well. We know the exact value of the cosine of 30 is square root of 3 over 2, and 1/2 for sine of 30. So there's your exact value. The exact value for the tangent of negative 2,730, well, that would be the same thing as the tangent of 150. which is the same thing as negative tangent of 30, which is equal to negative square roots of 3 over 3. So you can see how all of this all fits together. If you wanted to get really crazy, you could even say it's sine divided by cosine there, and you would have gotten the same answer. I hope those practice problems made sense and you were able to get a lot of those correct, and I will see you soon. Good luck with the trick.